Hello and welcome. I'm Bill Wake. We're working on an Elm interpreter. We recently finished working on operators, infix and prefix operators. So we have basic arithmetic going now. And I wanted to come back to something we did earlier. We did function definitions. And we didn't really check that we could handle recursive functions. And since that's kind of a core part of a functional language, I thought we'd better give it a go. So with arithmetic, we can do things like if x minus 1 not equals, if x equals 0, return if x minus 1, otherwise f of x minus 1, stuff like that. So we get some sort of recursive cycle going down. Without operators, we didn't have a real way to shrink anything, so it made testing that impossible, at least for me. Okay, let's see. We have run tests this morning before you got here. Okay. So let's just start in the RIDE. And if this just all works, then that's gravy. it's sort of supposed to, so All right. So if we did function of x equals if x equals, oh, sorry. I have some disk issues, I think. All right. If x equals, oh, we don't do equals yet. Okay, we can, no, we can't. How can we do this? Well, I was going to try and switch to Booleans. Wow, I didn't get all the way through a single if statement before it blew up. Let's see. So I was thinking, oh, I could do if x equals false, then true, else not x, or something like that. But I don't think we have the Boolean operators at all, and I'm not sure it even has a not operator. I think it's a not function that's defined. And I don't have if x equals 0, but my theory was if x equals 0, then let's if x equals 0, well, one way would be let's count it, then 0, else function of x minus 1. Okay, I think that's a legit function. If x is 0, then return 0, else return function of x minus 1. So basically this is going to give us 0 for everything. It'll count down positive numbers. I guess it would blow up for negative numbers, but yeah, so if you pass in 2, it'll call function of 1. Function of 1, it's not 0, so it'll be function of 0, which will come in and be 0 and get the result 0. We could make it more interesting. Okay, this is the constant 42 function for positive x values. All right. However, it's great to say it's there, but if we evaluate it, I'm pretty sure we'll find there's an undefined operator error. Okay, I'll accept error as a version of that. Well, maybe we got to deal with Booleans today. Maybe that's just the real investigate what we do for user-defined types and how Boolean gets initialized. Okay, let's move that one up. That's our mission now. All right. So if we say false, and evaluate that, we get the constant false. And if we say true, we get true. And I don't know what we get if we say bool. Yeah, not really anything. Okay. I don't know what we get in the REPL either, the real REPL. Type? Okay, I can't find. Yeah, that's. And here's some names that are close to bool. You probably misspelled it, right? Okay. Let's see. I guess after bool, we didn't know what to do. Let's find bool. Okay, we got a bunch there. All right, I'm changing the title of the episode officially. Let's go back to Booleans. Ta-da! Okay. Comparison operators, including equals equals. Well, this seems to be our definition of it. Okay, so bool type is a custom type Boolean with values false and true, and that's exactly true. Now, okay, yeah. So what we've got is, well, we sort of have our symbol table, and this is maybe a chance to unify things a little bit. This predefined custom types, basically, if you see the constant false, it can go back to this type and talk about it. Same thing here. But I think this, well, this is our parser. I don't know where our symbol table is coming into it. Right. So, I mean, look up custom value. Well, we'll go find where that's called. But basically, it takes a predefined custom type and returns the value if it knows it, and error if it doesn't, which is probably okay. But what's funny to me, if we go to interpreter, we have custom values, but I don't think we have them in our symbol table. So where's the main interpreter? So, okay, we put in our operators. String to expression. We're not putting in our custom values, and we really need them to do evaluations. Now let's go back to interpreter. Lock that down. Okay. So here, I mean, we're kind of getting to the point where things are getting more real, and so we need the predefined values around. We got the operator primitives, the prefix operators, but we don't have the Boolean type. And there's probably others, right? We saw error and okay, and who knows what else is out there. But I think the time has come to add them. But what's going on here? Back in Parserville, when you see a custom value, let's find the usages of that. One caller. Okay, so this is our main expression thing. If you see a name, you look it up, and if it's an error, we return an error. Otherwise, we just wrap it in a custom value. Okay. A little weird, but not totally off. So we see bool. I guess the deal is, like, we really need the Boolean type to exist at interpretation time, not just parser time. So here it exists at parse time, but nobody references it. We don't support 3 equals 2, right? But that's defined as a Boolean in Elm. Let's see. 3 equals 2 should be bool, right? Things are not going well for my disk. Okay. Let's see. So we don't support 3 equals 2. Maybe that would be a step forward. And really the equals operator has to return a Boolean type. Now we have the Boolean type, false and true, to, make use of it. It's sitting right here. All right. Let's put in another operator then. Let's put in this equality operator and see where that goes. And I don't even mind using the prefix form just to get started. Precedence. Okay, well, let's not worry about that. Where's our lexer? Okay, operators double equals is a valid operator. So we're okay to do that. We get the token. Let's find who's calling is operator. Okay, that's again, we have these operator expressions, but well, the prefix operator should be okay. Yeah, so that would be the 3 equals 2 stuff, but we don't yet support this, which should fail, but it's legal syntax. Okay, so it doesn't recognize it as a function, but it should be one. Let's try prefix. Okay, token prefix operator. Get return variable of name. Okay, so this is expression. When it sees a prefix operator, it treats it as if it were a variable of that name. All right, and that list of, well, let's just find one. We know this one's out there. Primitive functions. Okay. Yeah, so here's our list of these things. We don't support equality testing, but we would like to. So, okay, I think this is just like we were doing yesterday. We'll start with primitive functions. Okay, so here's a prefix operator. Let's check this one. Now, this will be interesting. The expected value. Okay, let's take 7 equals. Let's just keep the types consistent for now. I don't know what we're babying along, because equals in Elm can do more types than just integers and floats. But let's see. So integer value, we expect well, I think we expect variable based on this. Where's our uppercase? Okay, so if you use a custom value, the result of it, is just a custom value. All right. And we have to have this type. Let's borrow this. Somehow this has to get up into our domain. So let's put it here for now. And I'm putting it in this side because this is the interpreter side. The other is the parser side. They need to be the same at some level, but I think we'll start here. Okay, so if you do this, then we should get a custom value. and of name, which is true. And do we need a type? Yes. Okay. And this is our bool type. Did I call it bool type? That'd be a great name for it. Can I do this static? I'm going to put it in primitive functions for now. Okay, so this should be primitive functions.bool type. Okay. Check prefix operator equals integer, and he hasn't realized that exists yet. Okay, let's try. This test should fail with a similar error because the equals is not a defined function. All right, unexpectedly found nil. Line 68. Primitive function test 68. Okay, so yeah, so here it's assuming that we have the operator available, and we don't. So that's easily fixed, or at least it's fixable. Equals. Well, I guess before I do that, I don't have an equality function that really works. This thing is sort of like this, that it'll convert double into double to compare them. Actually, I don't know. Is that true? Can we compare? We can. Okay, so we can compare floats, and integer versus float compares. Okay. Right, but so we need a function that we could plug equals in here, but it's got to be a very capable one, because it's got integers and floats and booleans, and that's all we have for types right now. But in general, a user-defined type, once we start allowing that, you should be okay to convert it and test it. Let's define one here. My type equals this or that. Oh no. How do you define these things? I mean, we looked at it less than 24 hours ago. You would think. Type alias custom types. Oh, type. Okay. Type my type equals this or that. Now, can I say this equals that? Yeah. And hopefully this equals this. Yes. Okay. So yeah, we're supposed to be pretty flexible on this equality thing. So let's define a function. Convert numeric is not quite it. Convert function double. Okay, I'm going to imagine some new function that is like convert to compatible. And if we give equals, that's tough, right? Because equals... Maybe equals just needs to be a special case. We still want to curry it because it's going to be two expressions. All right. We will back up a level. Okay, so here's an example of this one. Let's let's just start simple because this is the reason we put things off is because they're hard, right? So if x is 7, y is 2, and I call convert equality no argument xy. Okay. And this doesn't exist. And we expect the result to be custom value false primitive function dot bool type. Okay, now this thing, make sure I'm happy here. Integer 7, integer 2, get this primitive convert equality function, pass the arguments, and get the result. Okay, I'm good with that, I think. Let me paste that name here, and we'll just borrow, well, we'll steal this for now, but I think we'll want to be a little more general. All right, so convert equality. It does not take an expression because we're going to hard code the equality test. But it does return a function of 2 arguments that return an expression. So we have the 2 arguments. So notice, I don't know if I mentioned this much, but this is asking for a function of 2 arguments. We're doing an implicit return. I think I could say return this, and I don't think it'll complain syntactically, at least about that. I'm returning a function, a closure, which is a function of 2 arguments. So if we're just, the only statement is a return, you don't need to use the return word in there. So the function of 2 arguments I'm returning takes x and y. If x is an integer and y is an integer, equality. Maybe I should pass in. Maybe I should pass in the equals. Because I would like to be able to do this with less than the same way. And yeah, I think I will undo a little bit here. Okay, so you have to give me an int function for equality comparison. And what I'm going to do is I'm going to call that int function, but it's not int goes to int, it's int goes to Boolean. Okay. I'm still returning an expression, but now I'm going to call this, and if the thing comes back true, I'm going to return custom value true bool type. Otherwise, I'm going to return custom value false bool type. All right, and I'm surprised it doesn't make me say primitive function dot. All right. This, however, let's take that out. That's me jumping ahead. All right, so we need our test should fail before anything happens. So we'll take equals as our function. Has no member. Okay, so I think we can build and run and fail. We'll get back an error function type. we blew up on primitive operator? Oh, because... Okay, let's unwind one test. Is that this one? Yeah, let's take this out for a moment. We're going to test something simpler. We're going to test our equality test. It's the problem with programming semantics. You get in there doing the same thing at the same thing. When you see the papers, they write things in all these different fonts. So, you know, this font is the real Boolean expression in logic, and this one is the one in our programming language, and this one is the interpreter, and, you know, and all these little things you're trying to distinguish. Okay, but this fails. That's progress. Okay, we can take this back out. And I think I expect this to pass now because I think we did it properly. So we get the two integer values. If they're both integers, then we convert. Run the integer comparison and get true or false. Okay. Let's run and see if it passes. Yay. I still don't know why my system's not beeping. Okay, there's got to be a... No. There it goes. Okay. Let's see. Okay, so that passed. Let's go to our other case. Now we want to do this one again. This is still going to fail because we don't have that thing in the operator table. But let's go put it up there. Oops. Right, so we got equals. We're going to curry our convert equality. The int function is that. And that looks like the others now. And this happens sometimes when you TDD. You sort of go in a level, things aren't ready. You back it out, back up that test, do a test at a lower level, make that work, go back, try and get the original one working. Convert, one failure. Okay, what's the failure? False is not equal to true. Well, at least we're in the Boolean domain. Okay, that's progress. Where's the test itself? Well, no. That is the case for 7 not equal to. Okay, and let's see, that name convert equality, that's not really good. Let's go there. Because this function should work fine for less than or equal, or any of those relationals. So maybe this is more like convert relational. Relational. And I could almost say operator. It doesn't hurt my feelings. Convert relational operator. You give it a relational operator and you're good. Okay. Now, okay, we'll make sure tests still run. I don't see why it shouldn't. Okay. Well, I don't really need those diffs. We added support for equals on integers. Okay. Can we run it? We might maybe we can get back to the recursive thing. I think we'll backfill all these operators though, because we're starting them. All right, so my question was, can I do this? I'll put it in double parentheses. If I have equals x0, then 42, else function of x minus 1. All right. So we're saying this function is if you're 0, then it's 42. Else we'll take the function of whatever you gave me minus 1. So function of 2 is function of 1. Function of 1 is function of 0. Function of 0 is 42. I would love this to work. Okay. It's just not quite there. All right, we'll keep recursive functions on our stack for a bit. I was really hoping that would just work. Let's try equals to 3. That should work. Equals to 2 should work. Equals 2.03 should fail. Type issue. That's a very odd message. Integer divide can only take integer values. Oh, did we left that? Yeah. Okay, we didn't have a test for this part. Let's do that. Really, this is for types that we don't handle. What type are we never going to handle? That's hard to know. Well, in the end, this thing shouldn't fail because we don't. I think equality is going to be defined for everything. Well, no, that's probably not true. Let's try this. So how about function of x equals x, g of y equals y, function equals g. Yeah, okay. So we do have that fallback. That's a harder test than I want to make. I'm going to push the problem. So what I'm going to do is we're going to do the double types. So if either function is double, we're going to call the double comparison. And if we don't recognize it, we're going to make sure our error message is right. Okay, so let's do that, if that makes sense. I don't know if it does. So my idea is the failure I expect when I mix values. We do want this to be false. 7 does not equal 2. And let's just, go back to Elm again. Does 2 equal 2.0? I think it does. Yes. Okay. 7 does not equal 2 is what we expect. Now, when we run this, we want to expect a message like these values cannot be compared relational, something like that. What we're probably getting is something about int divide. Yeah. Okay. Let's get the error message right. And then as we go on, we'll squeeze fewer and fewer things that can compare like that. This will be our sort of unsupported thing. All right. So I don't want this error. I want types are how about values are not comparable? Values are not comparable. Okay, because this is a comparable operator, a relational kind of thing, down to the V's. Okay. Now, this is not, we're still not getting the right, well, we're getting the error we expect when we don't support things, but we want to support Boolean comparisons. Okay. Let's go see that. Yeah. Okay. But we want them to be comparable, so we have to do the same kind of thing we did before. We're going to, I'm okay doing this in one step, I think. We're going to adopt some of this behavior. Yeah, something like this. This is our convert numeric types. And we're going to convert the left to float. We're going to attempt to convert the left to float and the right to float. If they convert, then we're going to do this rest of this. We don't have a double function yet, but I'm basically going to take this. Oops. Okay. So we're saying run the double function. If it comes back true, return true. If it comes back false, return false. And we don't have a double function, so let's get it in there. Int function bool expression that. And we want okay. Function at escaping float, no, double goes to Boolean. Oh, I'm in the wrong place. That's why the format's so funny. Oh, yikes. Okay, int goes to bool. Returns expression. Oh man, how have I done? That. Okay, let's borrow the header as well. I see no reason to get that wrong. And these will be bool. Okay, is that better? All right. So if it's an integer, treat it as an integer. If either one's a double, treat it as a double, otherwise fail. Okay, and now nobody's passing in. We need the double comparison operator in Swift. Okay. And same thing here. Okay, and my bell rang. Yay. All right. I don't think that's too traumatic, is it? All right, it's got some room for improvement for sure. Okay. let's check it in. We handle equals for floats. But I certainly, well, I want to get some of this repetition out of here. All right. I feel like, I don't know, this is getting so abstract it gets a little hard to follow. But I feel like you could do a type generalization over this and make a bracket T kind of thing and use Boolean or other. But the stuff you do with it when you get it back isn't really the same. All right, let's just tackle this tiny bit of Boolean stuff. So this int function that's a Boolean, Swift Boolean value. We're converting it to a custom value. Twice. Soon to be 3 times. Let's we want to do an extract on this. Okay. And my quick way to do this as automated as possible, unfortunately we don't have inline, but I'm gonna take anything I don't want, things I want as parameters. I don't have anything that extracts a parameter back out if I extract the method first, unlike Java or C# has these refactorings built in. So I do it in advance. I'm going to take out this. I'm going to leave the name because I don't really care. I'm going to repair it later. All right. Now this I should be able to extract method on. And this is Swift Boolean to Elm Boolean. Elm Boolean. Okay. And now I'm going to pull this back in. Cannot be used on primitive functions. Well, he's static. Okay. That's better. Yeah. All right. So now I can pull this back in. And if I had my automated inline, this would be 3 keystrokes. Extract a variable, extract the method, inline the variable. Okay, and I don't reference this now. So this should pass. And we'll just use the other one very shortly. Okay, and this then becomes Swift Bool to Elm Bool of the function value. And that's all in the method. Okay. Now we just introduced Boolean for today's work, so we don't have to worry that it's affecting anything else in this file. I don't know the duplication between the parsing side and the interpreter side. I'm not sure what to do there. We're going to have to figure something out, but for now, this is okay. All right. So, excuse me. What we have then, right now, we can handle ints, doubles. We'd like to be able to do custom types too, because we'd like to say false equals false. Again, let's do it. Can we say false equals false should be true? Yeah. Okay, so even if all we do is support Booleans for now, I'd still like to be able to compare them. That's perfectly reasonable. Okay, so the difference is this is not a simple equality. Now we got custom value. Let's open that custom value. He has an equality that looks at the custom value and decides if it's the same It's not full blown, but it supports the Booleans we have. And this is called by equals on the parent. Equals. Yeah, so if you compare if you compare two expressions, then it tells you if they're equal. Now let's just check our functions. Oh boy. What will they do if somebody says equal? Oops. Function call. The elements are equal. Yeah, that's not really going to help us. Okay. But we do know custom values work. Okay, so let's check custom value false bool type primitive functions dot bool type, and I'm going to break this line up because it's just getting too unbearable. Custom value false bool type, custom value, well, let's take false again just for variety. Bool type, and the result should be true. Does false equal false? Yes. All right, and we expect an error because we don't have that type comparable yet. Now, I don't know about relationals. False less than true. Work on lists as well, but it's better to find a different path. So equality is a different kind of thing. But I think I can say false not equal true. Yeah. Okay, so this is really equality testing. All right, let's we're failing. We'll rename that convert relational. It's going to be convert equality test or something. But it's failing because we don't support custom values. All right. So we're going to do something like this, except we're going to be working in the custom value type. Okay. So if we have two custom values, I think we're going to have a third function. Lord help us, that's a lot. This function is a expression function. Okay, and swiftbool to this expression function x. This is just xy. Okay, so we need to pass in a third function. Oh goodness. X function. expression function takes two expressions. All right, now our callers don't have this third function, but it's yet another equality test. Ugh. I know. I think this is as many as we will have on here. Okay. Oops. Only 3. This test can have the 3. Okay. What's your problem down here? Okay, let's see how that does. And we expect to pass. All right. Okay, and just to verify it at runtime. Equals false, true. Should be true, false. Yeah. Equals 3, 2.0, 3.0 should be true. All right. Now, last thing yesterday, we modified the padding on that, and here it is squeezed in again. That's weird. Okay. Support equals on custom values. All right. We're due for a break, so let's go ahead and take a 2-minute break. We'll come back. I think we need to rename that function. We can also do the not equal operator, and I think that gets us through those. Then we can do the infix operators as well. All right. See you in a couple minutes. Hey, welcome back. All right, let's do some. Let's get things on our to-do. I think we're backing things up a little bit. Okay, false. I bumped something. All right. We want comparison. Well, equality operations on int, float, and bool. Okay. I think, well, we're halfway there. We got equals and not equals. Okay. Recursive functions are still stuff, but I think before that we're going to do Infix equality operations. Okay. And that will consider to be part of, well, let's pull them out separately. Support equality operators. Okay, so that's kind of that. Okay. Equality operations. Okay, so we've done the equals. We got to do the not equals. Now, well, I think we're in good shape. Put it that way. All right, so this is getting a little crazy. Let's break it up. Prefix operators. How about numeric and equality? And so this loses the equalities. And this loses the numerics. All right, and we said this function we've been working on, that should really be called convert equality operator. the name's still not perfect. But we'll get there. We'll get better anyway. Okay. I'd really love to make this quicker to say. I think we can predefine false and true. That would help. Let's commit that. Okay. Custom value false. This should be. I think I can. Call it Elm false. And then Elm true. Okay. I like it better already. What's the complaint? Yes. I don't know if we take the static off, maybe we're okay. This is Elm false. This kind of gets back on one line. Okay. Now I think we want to do a similar thing for the Elm not equal. And since it's the opposite, it should just be the opposite of the expected value. Okay. So I'm just trying to raise my gear level a little bit, go a touch faster on this. I think we can get all three for the same price. Okay, we don't have that in our list. Prefix Operator. Whoops. What I did there, Elm false is false not equal to false? No, that's false. But I wasn't wanting to edit that. I wanted to edit our table. Oh, this is not primitive functions. Interesting. Still not. That's more like it. I don't know. That's got to be a bug in Xcode. All right. Now this one. That's the one I wanted to muck with. But I want not equals. And I don't know. I think if you define the equals operator, you get not equals for free. I hope. If not, we'll have to do something. Should pass. Yay. Okay. So you can see as we get more mechanism in, things do get a little quicker. Int, float, and custom values. Okay. Now, I keep going back. All right, let's see what we got here. Equality operations on int, float, and that. Okay, so that's, I guess this is the 14th. Equality operations on int, float, bool. Yes. Now, I'm still a little unsure what's going on the REPL side, though. Let's see. We checked our values, so false and true. This should be false. Okay, and not equals false. True should be true. Okay. What? What's wrong with this definition then? How about function equals, no, let's just say bool value equals false true, which we know is false. Okay, bool value is a function from unknown to unknown. Something is weird. Can we say int value equals 42? And we should be able to do int value. Okay, but bool value equals some function. Int value equals 3 plus 2. 3. Our definitions are not picking up enough. I think it's only picking up the 3. I'll bet our definitions don't use operator expression. Where's parser? Equals function definition equals expression. Yeah, that's suspicious to me. If it's function calls, then right-hand side expression. Yeah, that's probably should be operator expression. So let's add that to the to-do. Should allow operator expressions on the right-hand side. Now, I'm a little less sure about the first one here, this bool value equals. That I think should have been treated as a function call. Let x equal how about, whoops, no let. How about function of x equals x? And then if I say function of 3, I should get, whoops, I'm doing separate evaluations. Okay, it's a function. If I do function of 3, I should get 3 back. Okay. Now if I say g of x, well, keep it g of y, equals function of y, what do I get? A function. G of 42 is 42? No, it's a function. So there's still something going on our right-hand sides on functions. So functions aren't evaluating functions on the right-hand side, I think. Okay, so there's Plenty of joy left here. Okay. Equality operators. Let's do the infix equality operators. We had operator. It has all these functions. And this is where we were converting them the same. And they really are the same functions. We do need to get rid of this duplication. It's really annoying me. Okay, but this is where we can apply our equality operators. So let's find operator tests. Evaluates percent. We want something that's more like int divide. And these are starting to look like they ought to be parameterized tests too. Maybe I should dig out evaluates inline. Well, let's just infix equality. Okay, token dot double equals integer value 3, integer value 2. This thing should evaluate to, well, do I have Booleans kicking around? Let's just say, oh no. Okay, this is annoying. Really, I should find my custom value in the symbol table. Let's see. Well, the true value is custom value false with primitive functions dot bool type. Okay, and that's in string. Do I have enough parens? Yeah. Okay, so evaluates infix equality, integer value 3, integer value 2. This should fail. Unknown syntax not implemented. That's correct. All right, and then we want primitive functions. Oh, what is this thing doing? Okay. We're going to do the equivalent of this in the operator world, which we don't have to put the curry on. This is double equals is dot convert equality operator with all its glory. Okay. Expected comma separator. No, you didn't. Okay. You need 1 equals. All right, and let's add our test for not equals. Infix inequality. Operator is token dot not equal. And not equal 3, 2 should be true. And comes back false. Not implemented. Yeah, that's better. All right, because he's not in this table. Okay, this is not equal. And we want the not equal operators. Okay. All right, so we support Infix operators equal and not equal. Quality operators, infix, yes. Yeah, it's a stack on the top half of the file and a list on the bottom half. Okay. There should be some clever zipper V-shaped thing for that, but I don't know it. Okay, we got those. Is tackling functions the right thing to do? Okay, we did that. Okay. Let's see what we can do cleanup wise. I mean, one thing I'm thinking is this stuff is it's redundant, and that bugs me. Okay, so that's the only way to say it. I would like to think, well, how can I say? Here's what happens now. I'll just sketch it out in to-do here. Okay. If you say plus 3, 4, you really look like a function call with arguments 3 and 4. If you say 3 plus 4, you look like an operator plus applied to 3, 4. Those are very similar shapes. And the fact is, the function we're using is the same function in both cases. We're just copying it in the two tables. I would love to, instead of that, I would like it to be function call 3, 4. And this function call is really with the parenthesized plus, and same here. I would like to just map them. And with the understanding that this parenthesis plus, like somehow I have to know that inline infix plus is the same as prefix plus. So I probably need a little table somewhere that says what does the infix operator map to. The reality is they map to the same thing with parentheses. So maybe I could just kind of cheat and wrap it in parentheses and call it a day. And use that to look up the function that it really is. That would be nice. And that's kind of a medium-sized refactoring here, right? I mean, this is not extract method or anything. The difference is, well, one difference is, or one question is, when I have these nodes, do I use the fact that they're operators? Or is this just a special case of being a function? And I think it's a special case still. I think the only reason I think we're comparing equality, I think our tests care about this. I don't think we do this in real life for operators. Okay. And the thing we have going on, and I don't know if this is good, bad, or indifferent, but when you have our expression trees, some of them represent constants, and they're the result of an evaluation. So you can evaluate an int value, you get an int value, floats, custom values, all the three of those, they evaluate, they produce an actual value. And all the rest of them, operators and what else we got? Definitions, closures, lambdas, lexer, all these other operators are other tree types. They're real at evaluation time, but the point of evaluation is to do the evaluation and end up with a primitive value, and primitive being int, float, custom type, arrays and lists of things, whatever else Elm supports. They're all treated as expressions. Now you need to compare the primitive types for their values to see if they're the same value. I can say, does 3 equal 4? But I can't say, does, like we had function of x equal g, does function g equal function f? I can't answer that question. It's not a primitive thing. It's used in the evaluation of others until it produces a primitive. Although we do keep, if you have the function, you have a something that is a value, argument to expression type thing. So this is kind of a big experiment, I guess. And I don't know if it's a good experiment or not. I think the thing it's revealing is like this table, has to match exactly to this table, modulo curry, but they should, plus, minus, times, slash, arrow, percent, equal, not equal. And we should have the same ones over here. Plus, minus, times, up arrow, float, divide, int, divide, percent, equals, not equals. Okay, we are synchronized, but that shouldn't be necessary. But now I'm a little worried. Well, okay, so in our translation here, these op functions, when you try and evaluate one, we call a primitive function. And that's completely what's happening on the other side. The only difference is an operator knows it has both values right then and there. The primitive ones, they're curried, so you can just pass one thing. So let's demonstrate that. That may give some insight. So you can say plus 3, and that produces a function, and it's a function that's an add 3 function. So if you call plus 3 with 4 as the argument, you get 3 plus, and then it says 4. Plug in the 4, and it's 7. Okay. Now there's nothing comparable for 3 plus 4. All right. So the difference is that prefix plus is a curryable or even curried operator. It's a function of one value which produces a function, and that function may be evaluated with another argument. Okay. So I am introducing trouble if I do that. Well, and this comes down to, let's go back to the precedence parser. Where's post order? Let's take a look at post order. Let's look at the real one. AIM. Okay. So the post order thing is getting a series of expressions out of the precedence parser. 3, 4 plus. And that says this is 3 plus 4. And it converts them. Well, it reorders them. No, it converts them, I guess. Yeah. I mean, here it is. Here's the operator. So you got 3, 4 plus. It pops the 3, pops the 4, pops the plus, or has the plus, and says, oh, I see. This is 3 plus 4. Let's make a plus operator call, operator plus, left-hand side, right side. And these may be arbitrary expressions. That's completely fine. They could be operators themselves. But the deal is when you have 3 plus 4 times this, parenthesize that, 3, 4, X, the names and numbers, they just pass through. And so they're coming in directly from the parser as, variables or integer values or float values or things like that. Everything else turns into operators, or it's parentheses and gets ignored. but reflected in the precedence and all that stuff. So I guess the spike version of this is we got an operator token. We're going to push something different on the stack. We're going to push what will we push for a prefix operator? That's what I'd like to do. Because when things get popped, they don't get looked at here. Like notice RHS equals stack last. It just passes it on through to the operator call. Nobody cares. Okay, so let's see. Let's figure out how the prefix plus works. And that's in where is that? Interpreter, right? Interpreter. Yeah, this has primitive functions, prefix operator primitives. It references that. Okay. So these are in our symbol table as functions ready to go, because curry takes a Swift function and wraps it up so it can call one argument at a time. All right. So when you call, let's go to our grammar. When you call prefix operator, we should find that in our list. Down here, yeah. Lowercase name prefix operator, yeah. So it says it's a variable of that name. And that's the same as saying function of 3,4 is just like saying parenthesis plus of 3,4. The variable name gets passed in, and then at some point, something is a function call. And that's expressions. Let's see, where's expressions with an S? Okay. A function call is basically a series of expressions. Function of 3,4, parenthesis plus 3,4. And this thing gets turned into a function call. So I believe what we can do if our post order, instead of saying prefix plus, instead of saying operator 3,4 said prefix plus, said function call of variable. Wait, I'm confused. All right, we got LHS is the accumulated expressions. Okay, we've built them up. If the first, function call just wants the list of expressions, so it just wants the whole list. All right, let's fix this name. It's not an LHS at this point. I'm going to call it Expers, a little bit of an abbreviation, but expressions is already taken because it's the function name. So let's see if we like this better. All right, now you're building up a list of expressions appending to that list and then passing the whole list to the function call. Right. So my spike, let's take the rename. And I will just run tests a little late, but kind of trusted the rename on that. Okay, so the spike is we want to convert operator, what now is operator, left-hand side, right-hand side. We're going to convert that to function call of the operator, a variable of operator followed by the existing arguments. Okay. And I'm going to do that how? I'm going to just duplicate the line. And this is my pure spike version of this. So I'm going to run, make sure things work like I think they do. I believe our prefix operators work. I don't believe they work in the context of function calls, but this 3,4 should evaluate. This in parentheses, 3, 4 should evaluate. Yes. Plus 3, 4 plus 2 should be 9. I think that should evaluate. Okay. Notice there's a little white gap over here that seems to be exactly this amount I wish this was going. Well, let's put that on the to-do just because it's caught my eye a couple times. REPL upper box should have padding on the left. And I thought we did that. Just peek. Yeah, that line, we changed that line yesterday and it seemed to work. But who knows? Okay. Don't need content view. And back in post order. So I'm going to change this line. I'm just going to make it be function call variable. And then I need to make the string version of this op. And I need all this in a list. And RHS. And we need a parenthesis here. Okay. Variable, and then I need parentheses to make this a prefix operator. Okay, so I'm saying instead of making this operator a node, we should just create the prefix operator node, which is normally variable of parenthesized op, and pass the LHS and RHS as arguments to the function. All right, and I'm just going to run because we're spiking this. We don't have a test somewhere. All right, and so that last thing I did was plus 3, 4 plus 2 mixing operators. Oh. A non-function cannot be called. Okay, let's find that phrase. A non-function cannot be called. Function call evaluate. There must be something else going on with that variable then. Or, well, where did that fail? Oh, it failed at runtime. If the result is not a closure and the arguments are not empty, let's run something a little simpler. One plus 2 now should come back as a function call. All right, that's the thing that's failing. Okay. Let's check our understanding on these prefix operators. How are they done? Okay, a prefix operator, it looks to me like it just gets wrapped up as variable of name. Okay, so this is expression. We see plus, and then so if we see the error is coming from function call evaluation. Let's stop in here. I think we're still running, right? So 1 plus 2. Evaluate should hit that point. Okay, let's see just what we got going on. Outer table is nil. Inner table has a bunch of values, including not equal and up arrow. You're going to make me guess them all, aren't you? There's plus. Okay, so our symbol table has the plus operator. Okay, let's see the expressions. We're expecting prefix plus 1, 2. Prefix plus, why is his name like that? Operator, yeah. Operator is a token. Let's take op dot. Oh, what do we got? Operator is a operator token. All right, I'm going to be even more spiky. And I'm just going to hard code the plus. But I don't know, is that... All right, let's try it. Whoops. Tests are not going to like this. Now this time I think our expressions should be, yeah, string plus. That's the thing you can look up, because here's the key, string. It's not consistent, but there's string plus gets us that function. So I'm going to continue. Oops, turn that off and continue and hope for the best. Hey, all right. This is promising. Okay, so this says if we can get the token name to be what we expect and not the spelled out English name of it, then we can pass that evaluation in. I'm happy. All righty. Let's see. So we've gone a while. We'll come back. We'll take, we'll revert this. And then we're going to make, well, let's see. I guess we're going to do a little work to make it so we can get that operator. Once we can do that, I think we can swap that thing out and be done. So 2-minute break, and we'll come back and move from spike mode to real mode. Welcome back. All right, so we're going to take this back out, and I'll leave this here as a reminder, but it's not hard to resolve it. Okay, our test should pass. Now I'm going to do something I don't often do, but this token, operator token, whoops. What we saw in there was as string has this stuff. It doesn't know the string that created it. That's interesting. It knows the token. It's like we really almost need the token string. Yeah. Let's see if we can get that from there. I don't know that we can. Oh, operator there. Let's see what we do for variable. That's probably the most similar one at this point. Alphanumerics, come in, A to Z. Okay. Lowercase name, that's fine. We do keep while, and then we build the token with that string. Now the operator ones, we keep the token, and we have the string. Token.prefix operator. Oh, that's those. Let's get to real operators again. Right. Yeah, we map the name. We don't keep the value. Let's see. I don't think. Yeah. Well, this seems like a pity. It would be nice if all our tokens just told us what their values were. But the reason is, let's get back up here. Most of these don't have attached stuff. And maybe token. Well, the deal is, it's handy to have these, like, this whole word is processed into it, and I mean, that's fine. Maybe it's more like the is operator thing. Yeah, so I don't know. I'm bubbling around between, like, well, I've got all these individual operators. Gee, it's not really helping me that much, because all I do is map them back in and say, oh, you're an operator. Okay, let's treat you all the same. So that tells me that maybe having these individual tokens for each one is not as helpful as I had hoped. If I had said operator and here's your string, would that have worked better? And maybe that'd be a way to go. I mean, the real thing is I got to get back from int divide back to //. I need to move between those two, / and parenthesis / and same for all the others. Now, can I print the string value of an operator? I don't know it anymore. I could put them in a big hash table and map them back to their text. But it seems like I threw that information away in the first place, and now I'm reconstructing it. So this is one of these changes. It's like I said, it's a medium-sized refactoring because it's a change to the behavior. Well, it's not going to change the overall behavior. That's how it's a refactoring. But it's not a simple one-step thing. I guess what I'm saying, All right, if I took all these things that were operators, anybody who says yes to this, and I just returned an operator token with the string form of that, would I be just as happy? I think I would. But it bubbles out. Well, okay, so what I'm doing is looking for an incremental path. All right, what if I had an operator token that takes a string argument, just like the name token takes a string argument. So up here, lowercase name takes a value of string. What if I had an operator that took the value of string? Could I make that go? I think I could. I can just do one. I can just do plus first and bubble that around so that everybody who's looking for a plus maybe has to go through the operator thing. Let's try that. Case operator, and it has a value of type string. Oh, okay. Op has a value of type string. That's a reserved word in Swift, so I can't really. I guess I can, theoretically, I can do this, I think, and turn it back into an unreserved word, but I don't know. It just gets confusing. Okay, now I got op. Whoever uses plus, well, let's find it in here. Dot plus. Okay. And who else? Somebody's got to, okay, he's got to decide here. He could return an operator plus. Yeah, okay, that's fine. So if I did that, anybody globally who's using plus is going to be affected. So let's look for dot plus everywhere. Yeah, lots of them. Let's deal with it downstream. All right, so if I had operator quote plus quote, who needs to know that? I guess. Precedence parsing cares, post order cares. Let's see that. Okay. Yeah, so I think what I can do, token operators for each variable x. So this is just a test. That's fine. Post order, I don't think cares. I don't see post order in this list, so post order is not doing it. This is just a test. If I said op of plus dot op of plus, var arithmetic op yields operator expression. I don't know. Okay, I guess it's doing. Post order does not care what it's given, so this usage is fine. I'm going to support both usages for now, and I'm going to work backwards from the output side to the input side and make things support op plus, even though it should have no impact on them. I mean, nothing will produce it yet, but if it did, do you do your job? Okay, is the test here. Okay, now the precedence parser, let's take a look at that. Table plus, okay. We need to make sure that plus and op plus get treated the same. But this doesn't matter. This just says if you put it in the table, it gets managed just like it should. We don't even care what the token is. And let's reflect that. Okay, so let op equal dot plus. And now I can use op in here. Op. And I can use it throughout. Op. Op. Anywhere the plus is. And the deal is the test is not even looking. It doesn't care what you call the operator. You're just throwing a token at it. And it makes sure that it creates all the entries in the table for it. Okay, so this token dot plus. Okay, this should be fine. Okay. Now if I make this token dot op of plus, yeah, okay, so we're big refactoring, introduce op plus okay, so that's kind of our strategy. Okay, let's search again. And I think the test is better for this anyway, rather than dot plus appearing all over the place. Okay, Precedence Parser Tests. Precedence Parser Builder, and I'm gonna do the same rule. It should be token dot plus. This is op. 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 And this will change in the long run because this is where it's looking for that operator token, and we're going to change it into a function eventually. All right. This should pass. It's just pulling out the op expression, but I think I can substitute my new one. If I do token op plus, right, that's only being used in here to make it. And so as long as it's a token it knows, we may have to say is token, is operator token may have to be modified for this one. I hope. Somebody should care. Okay, I guess we're still not at that stage. Let's find out who's using that. Who are the callers? Okay, well, token is operator. That's our parser. So we're still, well, we're still in the precedence parser, so that seems okay. Let's do a little bit more in there. Okay, so this one's okay. That's a leftover from the search. Try again. Precedence Parser Tests. Okay. Let's let plus op equal token dot plus, and I'm going to use that throughout. Okay. I don't see a difference there. All right. We'll do a similar move here. Oh, plus up. Let's change it and make sure that's okay. Plus. Well, I guess I can move a little faster. Let's go ahead and try it. Plus, plus. Plus. Okay. Press to token gets well, we're going to make this token op plus, and this is going to be token dot op plus. So this one is checking that if you have a token, we turn it into the operator token for it. So this is just a way to store that temporarily. And I don't think it cares what it's storing. It's just taking the input and wrapping it in an operator class, operator token class. Okay, press to token treats operators as lowercase name. I don't know what this means. Value is integer 3. If you say operator plus value, value, oh, whatever the operator is, we're going to treat it as as a lowercase name. That's a weird rule to me. I don't remember why we did it. Expression to token. Oh, okay, yeah. So this is saying if you've already got an operator with values, then that's the same as a lowercase name. So it's just saying if you had a variable or an expression, treat them the same, I think. The output shouldn't care on this. It's just saying any lowercase name. It's just a priority kind of thing. Okay, let's repeat our search. Okay, so we got it out of there. I guess I don't care about this one anymore. Okay, so we've made sure that Precedence Parser is okay with op tokens. Okay, now the table builder. Well, these are all tests. What do we got down here? Anything that looks operator? Well, that's probably going away, so he's not an issue. Lexer tests, parser tests will care. Operator tests will care. Let's deal with... Didn't we just get rid of that one? Yes. Okay. Let's deal with the precedence table builder. Okay. Yes. So I don't see that this should care at all. Dot op of plus. And I will allow myself to repeat it. Op plus is greater than op plus. Repeat the search. Okay, so we got it out of the precedence table parser. Okay. Operator tests. Well, we'll do this. Operator 1, reference to cross. Let's make sure that one's okay. I don't want to put too much into the operator test because I'm pretty sure they're going away, but maybe they may live on. Expression.evaluate. This, I think, will fail. Right. Excuse me. So we have expression operator was plus 3, 4. Our operator doesn't know how to work with this. Let's go to operator. Yeah, he's got a mapping for dot plus, but he doesn't have one for op plus. So let's add that. Op plus. Same exact stuff. And eventually this is going away, but keeping it working for now. All right, I think this will work again. Good. Why it got slow? 1.85 seconds. All right, operator token plus. And let's go back to our search. I think operator tests. Oh, still got one. Operator token plus. Let's take token.op plus variable name, operator plus variable name. This may change. We'll see. Right. The failure is, I don't know, it's going to be a plus, op plus. Okay, that's the default name of this thing. I think that's actually what we want for now. This what did it say we got? Yeah. I don't really care what the names are when you call as string. That's more a debugging thing than a real thing. We don't ever show that. So I'm a little puzzled why we bothered, but maybe we just wanted to make sure it's supposed to support as string, so some test maybe relied on it somewhere. And then maybe under the bad ideas phrase of things. Okay, we're knocking through them pretty good. Let's see if we can wrap this up here. Operator plus. Okay, now we've got that in operator. All right, parser and lexer. Okay, so parser tests. Well, this is a little bit of a... All right, I want to say this is equivalent to this. And I don't think that's going to be true yet. These probably all have to change at the same time. Okay, so I think we're back in a slightly TDD mode here. Plus, okay, these tests I think are going to fail because our operators come through as the wrong type. Op of plus is not equal to operator or plus. Okay, and that's coming from parse. Let's go to successful parse. Is that up here? Okay. It calls parse on it. So our parse does not yet produce pluses. All right, I guess the find. So parser, yeah. This precedence table, I'm going to add op plus. I don't know that that'll do it because I don't think we're getting the token yet. Yeah. Oh, where's our expected values? Maybe they just need to get the op. Three plus four, this, that. No, we're getting... This is the expected value out, so our parser is not returning. Well, I think we may be at the point we have to get the lexer going. Let's see how parser handles plus. Okay, there it is in the table. That's the only reference. Okay, yeah, so he's not getting it from the lexer. I hate to have to stack up like this. Is there a way around it? Well, the deal is it's passing through stuff based on the type of token it gets. So I don't think we have a way around it. All right, but we've reduced a lot. And that's okay. That's a little redundant. This is the one. Okay, I'm saying token op should be op plus, and this test is going to fail. Okay. And we know where that is in the lexer, or at least we had it in our sights at one point. Lexer. Let's look for token, character. There's plus, token plus, token.op plus. And well, let's see what happens. I'm a little worried about his operators. Okay, let's add .op plus. Okay. So what we've accomplished, use op plus instead of dot plus throughout. Okay. Now I think our find, there's this. Do we ever produce token plus? I'm not seeing it. We got plus, parser Swift. We still use it. We still use it here. This token op. Okay. The test is plus. Yeah, that. Oh, look for dot plus. Okay. So the Lexer has it in the list. Plus plus doesn't matter. Plus plus doesn't matter. It's this, and that. Okay, so at this point, I think we can delete plus completely. Any reference to it. That's not one. This is. And that one doesn't matter. All right, this should still be done. Okay, we've removed old token dot plus. That was not bad, and I think from here we can do a lot of them pretty quickly. Let's go to Lexer. We're gonna take token.minus. That's a little trickier to get to because of comments. There's token.minus. Okay, I'm gonna take every token.minus and change it into token.op minus. Op minus. Okay, and that. Okay, so throughout, if I find dot minus, I'm just going to change them all. I guess I don't need that there. I'll just take this much since it seems like I can do that. Minus should be op minus. Check token op minus. And everything should pass. Right. Okay. Lexer. I'm going to close others. And we're just going to work down them. Probably the place to look is this thing. A star. Dot star. And we want to change that to op star. And I can do replace, right? Text containing dot star should become that. Dot op quote star quote. Okay. Okay. I guess we did minus and token. Start with op version. And going through here, float divide. With op slash. Okay, so find them all. Place them all. Okay. So I think the process we did, right, we took one of our operators, we worked right to left to get it in so that it would work. We had to kind of pause in the middle with the parser and get the lexer switched over at that point. But once we did that, everything else just worked. So we reduced the number of references to those things quite a bit. And so now when we do this, we're getting, 7 references or whatever. So that seems okay. And I'm going through the list on the page and trying to make sure they make sense. Okay, so now, well, we just did op, replace float divide with op. All right, now int divide. This is our first 2-character one. So it's a little more fraught, I guess. But, it's being used very similarly. This is the 2-character token. So we're saying if you see // replace it with int divide, which is //. Okay, that all looks good. Okay, so we will try to replace all and test. Okay. What was my replace? Int divide. Dot int divide. Oh, missed that. It was int divide doesn't handle float. So this should be error messages dot. Whoops. I'll turn that off. Int divide doesn't handle float, and that messed up 2 places, right? Error messages dot int divide doesn't handle float. Okay, let's try again. And things like that are why we don't do them all at once. All right. Change token.int divide to op. Okay, %. To .op of this. Let's find them. And I don't see the error messages. %. There's one. I'll do them a little more one at a time. That one's okay. This one changes, I guess. But that one doesn't. Okay. That's an error. Okay. Place that one. Now, at some point, I keep getting to, oh, I guess our isOperator token will be able to simplify that. It's still working because we're replacing all the pieces. All right. Up arrow. Becomes op of up arrow. Looking for any textual kind of ones, but I think they're all okay. Let's try them all. Okay, this doesn't sound like a 6-minute job here. We'll see. Okay, double equals goes to op equals. We'll find them all. I'll do a couple. What's any error messages? So we'll replace all. Oh, we don't want to do less than first. Okay. Let's do less than or equal. Press all. We'll have to be careful with less than. We'll do greater than or equal. Oops, didn't replace them. Should pass because it's testing less than or equal. Okay, ampersand, ampersand should be easy. I don't know if we're even using it anywhere. Now this one is a trouble case. All right. I feel so close, and we're at the end of the time. So I will be back tomorrow, Thursday, 1 to 3 p.m. Eastern time, daylight time. And but I'm going to keep going. I think we're 5 minutes away from finishing the ops, and we'll pick up tomorrow. Simplify is operator, and move towards getting rid of the operator expression value. Okay, so let's see the less than. That's good. We got less than, less than. I don't know what less than is. So let's find these one at a time. I mean, I know what it is. It's not an arithmetic operator though. Less than bar is the same situation. Less than replace. Oh dear. Let me revert. Do my find again. Less than goes to less than. All right. And then our last operator, greater than. we're going to replace it with op greater than. Find them. Okay. And I think those other ones, the op greater and stuff like that, we'll get those eventually, but they're not in our list of operators we support yet. So when they become supported, we can take care of that. Okay, and I will leave the rest for to do. We'll commit this. Handle listen and greater convert to token.op. I wasn't very consistent on messages. Okay, so this is I guess it's still Infix Operators is the story, but what we're doing is we removed use of plain operator tokens, consolidated them to token.op of plus, etc. All right, that's legitimately done. Okay. Now we want to remove, this is still story infix operators, I guess. We want to remove usage of old token operators from token, etc. It's only token, I think. We want to modify is operator, well, simplify is operator if it's still needed. And we're still in the process, this giant refactoring, or moderately large. We're still trying to change to use prefix operator function call instead. Well, let's say it that way. Prefix operator function call instead of operator class, and then eventually we want to delete operator class. All right. Yeah, so it took us a few extra minutes to get those last couple operators, but I think we've made good progress on this, and next time we'll get rid of all the ones that we just supported and go from there. So catch you next time. Appreciate you being here today. Thanks. Bye-bye.